Okay, good morning. Listen, uh, already we have come across about these concepts about the forward bias. Forward bias, P variety connected to the positive end of a cell or a battery. N variety must be connected to the negative end of a cell or a battery. Then it is called by the name the forward bias. There is a circuit idea in the form of circuit symbol and circuit symbol for diode and circuit symbol for battery or a cell. This is forward bias. P is connected to positive end, N is connected to negative end. Then I can say here the holes are repelled here. Now holes in P type repelled and electrons in N type is going to get repelled, and hence the charge depletion region thickness is going to get decreases. The thickness is going to get decreases here, and hence the resistance of the diode is said to be a very low value. And hence there is a current is flowing due to the majority charge carriers. There is a flow of current, and that current is a larger quantity here. Diode, we can say for all practical purpose, we are going to say diode is conducting. We are going to say diode is said to be under conducting if it is said to be under forward bias. Forward bias characteristics, already we have studied about that. Okay, quickly I will finish it off. We are connecting a battery here, and we are connecting a millimeter to measure the current, how much it is flowing here. As you are increasing the voltage here, more and more voltage, here the current is said to be equal to 0 in steps of 0.1, 0.2, 0.3, 0.4, like that. If we are increasing the voltage here, current remaining as it is equal to 0, because this voltage is lesser than the junction potential. Since the voltage whatever we have applied is lesser than the junction potential, no current is passing here. If it is equal to that, then the smaller current it is passing. If it is more than that, then a large current it starts to flow here. Then only a large current it starts to flow. And as you are plotting a graph, you are going to get a curve like this, and the current versus voltage. In the positive x-axis, we are supposed to plot the current, and the positive y-axis, in the case of x and y-axis here, along the positive x-axis, we are supposed to plot the voltage. Along the positive y-axis, we are supposed to plot the current here. Then we are going to get a curve like this. Starting, we are going to get 0, 0, 0. Then it is go on shooting up more and more here now. So where the straight line graph is there, where we are supposed to draw a small triangle here, exactly like that of graph sheet, whatever the lines are there. Along the lines only, we are supposed to draw a small triangle. This is the voltage, delta V. This is the current, delta I. We are supposed to write it here. Delta V divided, the small voltage divided by small current is called by the name the resistance here. Resistance is lower here. Okay. You are supposed to keep a scale here, and you have to draw a line where it is meeting on the x-axis here. That voltage is called by the name knee voltage. That voltage is called by the name the knee voltage. Okay, all these things already we are aware of these ideas. Okay, what is that next concept here? Forward bias, you are understood about that. Okay, yesterday also it has been repeatedly, it has been shown. Okay, now it is a reverse bias. If you know the forward bias and reverse bias, then the next concept for 5 marks and 3 marks questions are easy to understand. Reverse bias. What do you mean by this reverse bias? Reverse biasing means what? Reverse biasing means what is happening in reverse bias. And in the case of reverse bias, the circuit symbol and other things, how we are going to write. 2 things. Now, already we are aware of this. This is PN junction. This is the aluminum wire for the electrical connection. This is P variety and this is N variety. Here, majority charge carriers are holes. Minority charge carriers are electrons. Here, majority charge carriers are electrons because it is N variety. Minority charge carriers are holes. Still, I can write one more also here. No problem. This is charge depletion region. The thickness of this one is equal to 10 to the power minus 6 meter. The charge depletion region, the thickness is equal to 10 to the power minus 6 meter. Now, I suppose to explain the reverse bias ideas. This is the PN junction. This is your aluminum wire. Okay. This is containing a large number of holes. Here it is containing large number of electrons, provided if this is P and this is N. Now we are supposed to connect this P variety must be connected to this P variety must be if it is connected to the positive end of a battery, then it is called by the name forward bias here, but we are supposed to connect it to the negative end of a cell. Positive end of a cell, we are supposed to connect it to N variety. Ulta, reverse way. Okay. If the polarities are changed like this, then it is forward bias. If I'm writing like this, this is reverse biased. This is reverse bias condition. In this reverse bias here holes are present here now. Holes are the holes, whatever the holes are present here now, they are all attracted towards the negative type because holes are having the negative charge. I mean, holes are having the positive charge here. The holes are having the positive charge. Here, negative potential we are applying. This negative potential attracting the holes. Holes are having the positive charge. This is negative potential we are applying, and hence these holes are attracted towards the negative potential. Therefore, they are all slightly, they are moving away from their position towards the negative potential. They are all attracting. Here, negatively charged electrons are present here. Here we are applying the positive potential here. Hence, they are all attracting like this. They are all attracting like this. Electrons are attracting towards the positive potential, whereas holes are attracting towards the negative potential. Hence, we are going to get the junction here. This is a junction we are going to get. This thickness, the thickness of this junction, called by the name the charge depletion region, the thickness is increases. The thickness get increases. How we are going to write in the form of a circuit? This is a variable potential I will going to apply. Here we are going to connect a current meter, which is microammeter. In the case of forward bias, we have connected a milliammeter. Here we are connecting a microammeter. Micro 10 to the power minus 6. Milli there 10 to the power minus 3 amperes. Here 10 to the power minus 6 amperes we are supposed to measure here. This is a variable voltage. Already I told you about this arrow mark, what it indicates. We can increase the voltage or we can decrease the voltage. Then here, how we are going to show in the form of a circuit diagram. So this is P and N. This is P and this is N. This is your negative end of a battery. This is positive end of a battery. Follow this. Now we are supposed to connect P variety must be connected to the negative end of a cell. N variety must be connected to the positive end of a cell. If you want to have this variable voltage source, we can put it. If the P is connected to the negative end of a cell and N is connected to the positive end of a cell, then only this diode is said to be under reverse biased. It is under reverse biased. Either you are changing the polarity of the diode or you change the polarity of the cell, then it is converting in the form of a forward bias. P, if it is connected to the positive, N connected to the negative, if I'm writing, then it is forward bias. But here, P is connected to the negative here, N is connected to the positive, therefore it is called by the name reverse bias. This connection is called by the name the reverse bias here. This is reverse bias. Here we are going to connect a microammeter. This is a microammeter. Current flowing is said to be a very lesser quantity. Whereas in the case of forward bias, current flow is said to be a larger quantity. Whereas in the case of reverse bias, current flow is said to be a smaller quantity. Hence we are writing microammeter. Hence we are connecting microammeter here. Now what is happening here? Now this is a reverse bias concept here. But what is happening here in this case? Point number one. What do you mean by reverse bias? What do you mean by reverse bias? First idea, Pn is connected to negative end of a cell. This is a concept. Pn must be connected to the negative end of a cell. Number two, N, whatever the end is present, that must be connected to the positive end. N end must be connected to positive end of the same cell. If you are connecting like this, then only it is called by the name the reverse bias condition. This is called by the name the reverse bias condition. So Pn, P connected to the negative end, N connected to the positive end. Number two, as soon as if you are connecting here now, holes are attracted towards the negative potential, electrons attracted towards the positive potential. So holes attracted towards this negative potential, whatever we have connected so far, voltage source. And here electrons, they are attracted towards positive potential. Electrons are having negative charge, positive potential is there, they are attracting like this. Holes are present here, they are attracting towards the negative potential. Due to this aspect, due to this action here, charge depletion region thickness is increases. So in this case here now, charge depletion region, that thickness, the charge depletion region thickness increases. It has been get increases. As the charge depletion region thickness increases here, now 1 or 2 electrons are present here as a minority charge carriers, 1 or 2 holes are present as a minority charge carriers here, but here electrons are the majority charge carriers, holes are the majority charge carriers in p-type here, and the electrons in the n variety could not be able to move from here to here. Electrons here could not be able to move from here to here. Therefore, due to this one, I can say resistance is larger. Resistance is larger. It is a larger amount of opposition is present. Due to this larger resistance here, these majority charge carriers could not be able to cross the border. So I can say majority charge carriers could not pass through the charge depletion region. Pass through the charge depletion region. It has not passes through the charge depletion region. So again, you see that another 1 or 2 points I had to write it here. P variety must be connected to the N, negative potential here. N variety must be connected to the positive end of a cell. Then I can say it is called by the name the reverse bias here. Holes are the majority charge carriers in p-type. They are attracted towards the negative potential. Electrons are the majority charge carriers in n variety. They are attracted towards the positive potential, whatever we have applied from externally. And because of that one here, charge depletion region thickness increases. As the charge depletion region thickness increases here, these majority charge carriers could not be able to pass through here. As the majority charge carriers could not be able to pass through here, opposition here it is more. As the opposition is more to pass through the electrons here, I can say resistance is larger. Since the resistance is larger, here to here, majority charge carriers could not be able to pass through the charge depletion region because the charge depletion region thickness is very large. Therefore, electrons could not be able to move here, holes could not be able to move. Because of that one, here the current flow is equal to 0. I can say here now the current flow is equal to 0 because no majority charge carriers are moving. Okay, for all practical purpose, okay, point number 6 I will write here. Okay, practically I can say here current is equal to 0. Current flow is equal to 0. there is no flow of current, but there is a current. I said current flow is equal to 0, but there is a current. I will explain that. Why? What is that current? The current flow is equal to 0. Therefore, for all practical purpose, we are going to say diode is not conducting. Diode is not conducting. But under forward bias, semiconductor diode is conducting, we are going to say. But in the case of reverse bias, the semiconductor diode does not conduct. All practical purpose, diode is not conducting because the current flow approximately taken as 0. It is equal to 0. But I said there is a flow of current here. There is a flow of current. Which current is flowing here? I said majority charge carriers are not moving here. Majority charge carriers are not crossing the border, but here there are minority charge carriers. These minority charge carriers, they are combining here. Recombination of holes and electrons that takes place in N variety and P variety. Here electrons and holes are recombining. Holes and electrons are here, it is recombining in N variety and P variety. Due to these minority charge carriers, there is a current. But that current is very, very, very small amount of current. That current is said to be a very small amount of current. That current is called by the name reverse saturation current. Okay. See here, charge depletion region thickness is large. Due to that one, majority charge carriers could not be able to jump, could not be able to pass through here. Therefore, current flow approximately taken as 0. But I can say diode is not conducting here. Diode is not conducting. But there is a very, very small amount of current is flowing here. Small amount of current is flowing, which is not depending upon this voltage. Even if you are increasing the voltage, that current is said to be a constant current. Even if you are increasing the voltage here, current flow remains constant because it is depending upon only the minority charge carriers in N variety and minority charge carriers in P variety. P variety minority charge carriers, they are combining and producing a current. N variety minority charge carriers, they are combining and producing a current. That particular current is not depending upon this voltage. As you are applying the more and more voltage here, that current remains constant. That current is due to the minority charge carriers, not because of the majority charge carriers. As shown here, majority charge carriers could not be able to pass through here. Therefore, current flow approximately I can consider that is equal to 0. But again, I can say there is a smaller amount of current is flowing here because here there are the minority charge carriers are there. That small number of minority charge carriers, they are responsible for a smaller current. Here minority charge carriers are there. Therefore, in P variety minority charge carriers, in N variety minority charge carriers, they are combining and hence it is producing a very small amount of current. That current is called by the name reverse saturation current. Point number 8. So here, due to the minority charge carriers, there is a small current. There is a small current. That small current is called by the name. This small current is called by the name reverse saturation current. Reverse saturation current. This is called by the name the reverse saturation current. This reverse saturation current does not depending upon the external voltage. This current, okay, does not depend on the external voltage, whatever we have applied. External potential voltage, whatever we have applied, it is not depending upon this. Reverse saturation current, this reverse saturation current here, it is not depending upon the voltage. For example, let us consider 0 volts. Current is equal to something. Already current is there. 1 volt, current is same thing. 2 volts, current is same thing. Even 5 volts, current is same thing. 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, current is equal to the same thing. But at a particular voltage here, as you are increasing the voltage more and more and more here, now at a particular voltage here, now here more covalent bonds are breaking up. Go for the intrinsic semiconductor concept. They are all having the covalent bonds here now. More covalent bonds are breaking up due to this larger potential here. Due to that one here, more number of electron hole pairs are producing. Here also covalent bonds are breaking up more in number here, and hence more number of minority charge carriers increases here. Now here also minority charge carriers increases. Due to that one, here there is a larger current, it starts to flow here. That particular voltage at which covalent bonds are breaking up, hence a little bit more current starts to flow here. Now that particular voltage is called by the name breakdown voltage. This is called by the name breakdown voltage. So one more question, what do you mean by breakdown voltage? In the reverse bias situation, in the reverse bias condition, as the voltage, externally applied voltage, as you are increasing slightly more and more and more as you are go on increasing, at a particular voltage, more number of covalent bonds in N variety is breaking up, more covalent bonds in the P variety breaking up. Hence the minority charge carriers in N variety and minority charge carriers in P variety slightly increases. Due to that recombination of minority charge carriers, the current flow suddenly increases here. Now the current flow, whatever it is, suddenly increases at particular voltage is called by the name the breakdown voltage, which is breaking out. The breaking up is said to be here covalent bonds. So at a particular potential in the reverse bias condition, the covalent bonds are breaking up, hence the minority charge carriers number increases. Due to that one here, current flow, it is suddenly increases here now compared to the reverse saturation current, suddenly get increases. That particular voltage at which the current suddenly increases, that voltage is called by the name breakdown voltage. That voltage is called by the name, here it is, breakdown voltage. That is represented by V suffix B, breakdown voltage. This is breakdown voltage. What do you mean by breakdown voltage? Now reverse bias characteristics. What do you mean by reverse bias characteristics? Reverse bias characteristics. Okay, whatever I explained, that one only I supposed to do it. So P variety must be connected to the negative terminal. N variety must be connected to the positive terminal, connected through a micrometer with a voltage cell. Then I can say it is reverse bias. As in the reverse bias here, we are go on increasing the voltage. Here, P connected to the negative terminal, N connected to the positive terminal, voltage must be go on increasing. We have to note down the current. Here 0 volts, current is 0. 1 volt, current is maybe 5 microamps, not milli, micro, 5 microamps. 2 volts, 5 microamps. 3, 5 microamps. 4 volts, 5 microamps. 5 volts, 5 microamps. 6 volts, 5 microamps. Maybe 7 volts or 8 volts if it is given, suddenly the current is going to get increases to 100, 200 like that. Microamps, not in terms of milliamps. Even though it is 100 microamps here, that is also a lesser quantity compared to that of the forward bias. Because forward bias we are measuring in terms of milliamps. This is in terms of microamps. At that particular voltage, 7 volts or 8 volts here, now depending upon the diode, okay, here the covalent bonds are breaking up here more and more, and hence the minority charge carriers numbers increases, and because of that one current flow suddenly increases. That voltage at which the current flow is said to be suddenly increases, that voltage is called by the name breakdown voltage. That voltage is called by the name the breakdown voltage. So see here, this is the concept. Here we are supposed to draw a tabular column, V in volts, This is current in microamps. We are supposed to take 0. Here it is 0. Maybe 1 volt. Okay, something here now. Maybe it is said to be, I said already 5 microamps. 2, 5 microamps. 3, 5 microamps. 4, 5 microamps. 5, 5 microamps. 6, maybe it is equal to 5 microamps. 7, suddenly increases. Suddenly increases. Maybe at one particular semiconductor diode, one particular voltage is there. That voltage at which the current flow is suddenly increases. Maybe it is equal to 50 or 100 or 90 microamps. Suddenly increases. This current is called by the name reverse saturation current. This current is called by the name reverse saturation current. This current does not depending upon the externally applied voltage. Even if you are increasing the voltage here, that current remains same here. Now that current is called by the name reverse saturation current. Reverse saturation current, which does not depending upon the external voltage. But at a particular voltage here, current flow suddenly increases here. That voltage is called by the name breakdown voltage. It is called by the name the breakdown voltage. This voltage at which the current flow suddenly increases here now, that voltage is called by the name the breakdown voltage. That one we are supposed to show it in the form of a graph. How we are going to show it? Just you see here, this is x-axis and y-axis. Here if you are plotting any graph here, that is positive y-axis, positive x-axis. That is for the forward bias. This is for the forward bias. We are not plotting reverse bias here. Reverse bias we are plotting here. Here we are plotting reverse bias. This is for the forward bias. Forward bias you are going to get like this. Reverse bias, negative y-axis, negative y-axis, negative x-axis we are supposed to plot. How we are going to plot? Okay, just I will show it that also. Just learn it. Tomorrow there is no class, Sunday. Okay, Monday, you get ready with all this concept. Okay, that is most important. Like this. This is your voltage. Because we are applying negative voltage, don't forget. This is V in terms of volts. This is current in terms of microamperes. Like this we are supposed to draw. Microamperes. Current in terms of microamperes, V in terms of volts. I told you already, for 0 volts you will get 0. For maybe this is 1 volt, you are going to have 5. For 2 volts, you are getting 5 volts, 5 microamps only. For 3 volts, 5 only. For 4, 5 only. For 5, 5 only. For 6, 5 only. Like this you are getting. For 7, maybe you are going to get somewhere else here. This is for the 7 volts. For the 7 volts, you are going to get a larger current here. This is the current. As you are plotting all these things like this now, you are going to get a curve like this. And it is shooting up here. Where it is getting shooting up here now, this voltage is called by the name, breakdown voltage. The voltage at which the current flow suddenly increases, that voltage is called by the name breakdown voltage. There in the case of forward bias, it is a knee voltage. Here it is called by the name the reverse bias. The reverse bias, the voltage at which the current flow suddenly increases is called by the name the breakdown voltage. But reverse bias condition, even though the current is said to be here, it is maybe 100 micro if I'm considering, because it is a reverse bias. If it okay, Monisha, you are asking why we have to apply the negative volts. If you are applying a positive volts, it is forward bias. If I'm teaching only the correct one only, okay, it is no problem at all. If I'm teaching a wrong concept, that is reverse bias. Or both the concepts that we are supposed to analyze. Okay, let us go for it. So first we are connected, P variety must be connected to the positive. N variety must be connected to the negative. That is called by the name P positive, N negative if you are connecting, that is forward bias. Again and again, why we had to put forward bias? We had to see what is happening in the case of reverse bias. No, sir, P is also connected to the positive, N is also connected to the positive. It is not at all biasing, which is not biasing. I told you already, biasing means one terminal must be connected to the negative potential, another terminal must be connected to the positive. If P is connected to the negative and N is connected to the positive, this is a reverse bias. This is reverse bias. If P is connected to the positive end here, N is connected to the negative end, that is forward bias. So last two classes we have already come across about the forward bias. P connected to the positive, N connected to the negative. Now today we have to understand if you are changing the polarity here, what will happen? We have to think. If you are changing the polarity here, now the holes are attracted towards the negative end here, electrons are attracted towards the positive end, and hence the charge depletion region thickness increases here. Due to that one, resistance is said to be a larger quantity. Due to that one, here to here, majority charge carriers could not be able to move here. Hence, current flow approximately taken as 0. Current flow approximately taken as 0. But there is a smaller current is flowing here. That current, if you want to measure, you cannot measure using the millimeter. Forward bias, we are measuring in terms of millimeter. That millimeter, if you are connecting here, it will show 0. This micrometer, if you are connecting to the forward bias, it will show out of the scale. Out of the scale, it will show. It cannot measure because forward bias current is more, reverse bias current is very, very small, very small. Because this very small current due to the minority charge carriers only. As the voltage increases here, then the minority charge carriers numbers remain same. At a particular voltage, at a particular larger voltage here, the covalent bonds are breaking up, minority charge carriers numbers increases, and hence suddenly the current flow increases here. That voltage at which the current flow suddenly increases here is called by the name breakdown voltage. That is called by the name the breakdown voltage. That breakdown voltage only I have shown it. Here we are supposed to plot forward bias, positive x-axis, positive y-axis, negative y-axis, negative x-axis. We are supposed to plot the reverse bias. Negative x-axis, negative y-axis. We are supposed to plot the reverse bias. That one only I have shown it here. Okay, negative y-axis here, current. Negative x-axis, we are supposed to plot the voltage. Negative x-axis, voltage. Negative y-axis, current, we are supposed to plot. This current is called by the name the reverse saturation current. This reverse saturation current does not depending upon the voltage. As the voltage increases, the current remains constant. The current remains constant. At a particular voltage, current suddenly increases because covalent bonds are breaking up. That particular voltage is called by the name breakdown voltage. Therefore, for next class concept, I require this one just to see that if a diode, if it is forward bias, then I can say it is conducting. Conducting. Current flow is present. I is present. Current is present here. There is a flow of current. If a diode is reverse bias, then we are going to say diode does not conduct. As the diode does not conduct, then current is approximately equal to 0. I am neglecting the minority charge carriers. Majority charge carriers, no one is moving here. Therefore, current flow approximately equal to 0. It is not conducting. So remember this. So whenever the diode, semiconductor diode, if it is forward biased, it is conducting. If it is reverse biased, it do not conduct. Current flow is there, but it is said to be a very small quantity. Therefore, we can say if a diode is forward biased, it is conducting. Diode is reverse biased, it do not conduct. So tomorrow onwards, tomorrow in the sense Monday onwards, that we are going to speak only about this. Diode is forward bias. What is forward bias? You are already aware of that. P is connected to positive and N is connected to the negative. Then I can say forward bias. If the polarity is changing, P is connected to the negative and N is connected to the positive, then it is called by the name the reverse bias. Reverse bias diode does not conduct. As a diode does not conduct, approximately the current flow is equal to 0 because resistance is very large. The charge depletion region thickness is very large here. Here the charge depletion region thickness is very less, and hence the majority charge carriers are moving here. Here no majority charge carriers are moving. There is a minute current is present here, but approximately that is taken as 0 here because it is due to the minority charge carriers. Okay, this is the concept here. Any doubt is there, you can ask. Still 1 minute time is there. Okay. Yes, anybody wants to ask, you can. Yes. Anybody wants to ask the question, you can.